Hi, in this video I'm going to explain an example with rational functions with the case of reciprocal functions with multiple factors. In the previous cases we have seen we have these functions such as this one, this green one, f of x equal to 1 over x plus 2. Perhaps we will be adding something around here like a plus 3. In this case I'm just going to start with something like this, and I'm going to compare it with these other functions, and instead of having only one factor in the denominator, now we have two factors in the denominator. I'm going to start by signing out the similarities and then to show you how it changes. I'm going to start then by showing you this. This function f of x in green has a vertical asymptote, one vertical asymptote that you get by taking the denominator and writing x plus 2, and then you equalize it to 0. That is to say that x equal to -2, this will be my vertical asymptote. I'm going to write it here as a VA, vertical asymptote. So on the -2, I'm going to do my best to draw it as a line. We have this super nice asymptote here. This super nice asymptote, this is to say a line that will never ever be touched by the function. Cannot be touched by the functions here, and here it is. Here's my super nice vertical asymptote. And so the graph for this function, we could just right away, by the example we used before, just find out as this number 1, it's positive, the one in the denominator. We could just say, oh well, this will behave something like this. We start from here and we go all along. Well, it's pretty ugly. Go all along here, and then it will continue through here. Oh, it's too ugly. To here, and then we get to positive infinite here. And from the other side, we see that it goes all the way through here. Well, I'm not drawing it perfectly because I'm not much of a drawer. So, okay, we have this. This would be roughly the graph for this green function, f of x. And now the thing is, how would this change with the yellow one, with this other version? Now I'm going to sign out something to start out noticing differences, and I'm going to add something new for this function. As you can see here from the graph, there is a point in here that it's the point that the green function f of x touches here the y-axis. So how do we find this y-axis, this y-interception? I'm going to use then, in order to get the y-interception, you have to evaluate the function, this one here, and evaluate it with 0. So you can see you'll get this 0 plus 2, so the f of 0 will be equal to 1/2, and that is, in other words, the y-interception. It's equal to 1/2, and this is this point we have here. Roughly, I got it by drawing out a hand. This is the point where this function touches the y-axis. Now that we got that, I'm going to start sketching out this other green one function. By starting, I'm going to get the vertical asymptotes. But notice something, as we have here two factors, that is to say that we will have, instead of only one vertical asymptote, such as this case, we would have in this case two vertical asymptotes. One from this factor and another one from this other factor. So you take the first factor, you do again, equalize it to 0, and you get that you have this asymptote, vertical asymptote, in x equal to -2. And with the other factor, you do exactly the same thing. That is to say, you have a asymptote on +2. Now, before drawing, I'm going to sign out here the vertical asymptote. Before drawing this out, I'm going to find as well what would be the y-interception for this green yellow f of x. In order to get this y-interception, you have to do, well, pretty much exactly the same as this case. You have to evaluate the function with the f of 0, with value of 0 for the x's. So you will get something like this, 0 plus 2 on the denominator, 0 minus 2 all over 1, and at the end you will get to this. It will be 1 over this positive 2 times negative 2 will be equal to a negative 4. So we will get at the end that the y-interception will be for the f of 0 will be equal to negative 1 over 4. So I'm going to write it in here. The y-interception will be equal to negative 1 over 4. Now I'm going to sign out another similarity from the green function. The yellow one will as well have an horizontal asymptote. As you can see here from the graph, the function has a horizontal asymptote here all along the y-axis. You never touch the y-axis. That is why a horizontal asymptote. So in this case, for the yellow f of x, you will have as well an asymptote in the along the x-axis. So I'm going to draw it. I'm going to write it, sign it like here, horizontal asymptote HA. So in the yellow function, you will have a horizontal asymptote when I'm going to write it like this: y it's equal to 0, and on the other case, it will be as well y equal to 0. Now, to prove this out with this yellow one, we will do that a bit later, but to find any detail. Just for now, I'm going to leave it like this. They have the same asymptote in y equal to 0, and we will see some other cases and how this will change out. But so far, we just remain with this. So I'm going to now take away this green graph here. So I'm going to erase it here. I'm going to erase most of it. So you can notice I'm not much of a drawer, and I'm not much of an eraser as well. So I got here. I'm going to erase this out. Now I'm going to sign out this information we have here. We know that we have an asymptote in the negative 2 vertical asymptote, which is this one from here. I mean this the vertical one is this vertical asymptote. We have as well a horizontal asymptote in y equals to 0. It will be all along here, and we have another vertical asymptote in here in the x equal to 2. So the first difference we can see is that instead of having only one asymptote with the green function, we have now two vertical asymptotes with the yellow one. Here. Now, I'm going to locate in the graph my y-interception. This will be negative 1, 4. Negative 1, 4 will be around here. I'm going to sign it there. Now, how do we fill out the rest of the graph? Now, I'm going to do this method that I normally do, and it works in every case. And you may think that this is a bit large, but by the third example, I think you will get how this behaves. You will get the pattern. It has a very clear pattern. And just the last example, I'm pretty sure we'll do it in less than a minute. Now I'm going to do here the full steps so you can see it. And then the second example will be shorter, and the third one will be super short. Now I'm going to start out. The thing is, in order to find this out, I'm going to evaluate this yellow function with a value that is really, really close, with two values really, really close to this negative 2, but that are not negative 2. Oh, sorry, here. I have to erase this a bit. Here. Okay. Okay. Now I'm going to evaluate this function f of x, the green one, with a value that is slightly smaller than a negative 2. So slightly smaller than negative 2. I really mean it's slightly, very slightly smaller. So I'm going to evaluate the function with f of negative 2.00001. This is slightly smaller than negative 2 because it's slightly on the left of negative 2. But here the thing is, I already have the result for this evaluation. You can verify it with your calculator. I encourage you to try it out because it will be helpful. But the thing is, if you evaluate this negative 2.00001 in here, you will get a result, something really close, but not exactly. Will be really. I'm just going to round up numbers. You will get 25,000 in return. The thing is, this is a big number. The only thing you have to be concerned really is that it is a big number and is as well positive number. So I'm going to sign it out by writing here an arrow. If you get really close to -2, but from the left of -2, from here with a value, you will get super big and positive numbers. So I'm going to draw this arrow just to sign out, well, will it go on this side of the function. Now I'm going to do just the same with a number that is slightly bigger than -2. So I'm going to evaluate with f of -1.99999. And now here, I already have the result for this, and I think you will notice something interesting. The result for this evaluated in here, it's -25,000. That is to say that if you approach to this function from the right of -2, you will get a result, that is very big and negative. So I'm going to draw an arrow in here. It's going down, and it's very, very, very negative. Now I'm going to do the same steps I did here, but now with a +2. With a +2, a number that is slightly smaller than number 2, +2 will be, I'm going to use actually 1.9999. Now, as you may find this something funny here. The result, if you evaluate this in the function in here, it's again -25,000. And the only thing, it's aside that it's the same number that we got previously, the only thing we have to be concerned is that we got a big and negative number. So we will go, if we get really close to the +2 from the left of -2, we will get something really, really big and negative as a result. Now I'm going to do again a value that is slightly bigger than 2. I think you will find out, you will notice what will be the result. So if I evaluate 2.000001, which is just the same as this one here, but positive, I will get as a result a 25,000 here, which is a very big and positive number. The only thing I'm really concerned is the sign of the number. So it would be, yeah, I get really close, the function will grow insanely big and positive here. And now, now I'm going to do just two more things. I'm going to evaluate what would happen. I would ask myself, what would happen if I go a super big number now in this function? Super big number, I'm just going to say, let's say I'm going to evaluate a f of 100,000. F of 100,000. That is the result for this. I just already did inputting the 100,000 this f of x. The result is actually something like this: 0.000000001, which is a super small number. It's really, really close to 0, but it is not exactly 0, which has a bit of a coincidence with the fact that we got here a horizontal asymptote just under x equal to 0 in here. Now I'm going to do just one last thing. I promise it's the last thing. I'm going to evaluate here a negative 100,000. And in here, if you evaluate this, you will get just exactly the same number that you got before, the 0.000000001. That is to say that if you input a super negative number, you will get really, really close to the 0 on the negative side. Now, the only thing left now, we got here only arrows, 6 arrows here, and we got this point here in the center. What would we have to do? Actually, the only thing left to do is just pretty much joining the arrows and the dots here. The only thing you can do here to join these 2 arrows on the left, I'm literally going to join them up. I'm going to join them up like here. Sorry if it's too ugly. Just trying to do my best to draw this out. Now on the center, I just draw this first section of the graph. Now on the center, I want you to notice something. You have to join this arrow here with this one here. Now the thing is, you cannot cross this line on the center because it's a horizontal asymptote. You cannot cross it, so the only way you can do it, oh sorry, I'm going to join them up like this. Oh sorry, this is too ugly. I'm going to join them up in here. It will behave something. I'm just going to do it the other way. I think it's better like this. And so it will behave something very similar on the other way. And the last case, it will be the center, and on the right side it will be pretty much the same thing that before. We just join the arrows here, and that's it. We got our super nice graph for this. I know, well, actually no, it's pretty ugly. This is the graph for the f of 1 over x plus 2 times x minus 2. I'm just going to show you how it will look like in the Desmos here. So I'm going to show you here the graph with the Desmos, and here you go. Here it is. As you can see, this is slightly nicer than my drawing, but this is just nice as well. Okay, this is all for the first video here. Let's get to the second one, which is a bit more interesting.